Hi, this is Shawn here from 3M. Thanks for joining us today. As you can imagine, we get a ton of questions from out in the field about adhesives. So I've compiled a top 10 list here, and I'm going to tick these things off one at a time. So let's start with one of the obvious questions. What's the difference between these adhesives? So we've got three different adhesives. We've got one structural adhesive and then two panel bonding adhesives. What is the difference? And I'll address that in a second, but it may help to know what the similarities are first. So these are very chemically similar in a lot of ways. Number one, the chemistry is epoxy. So all three of these products are epoxies. Nice thing about epoxies is they handle heat very well. So there's a number of things we can take advantage with because they handle the heat well. Number two, they all contain glass beads. Those glass beads are in that product to guarantee us a minimum bond line thickness so we can't squeeze all the adhesive out if we happen to over clamp. Number three, they all have corrosion inhibitors. So you should be very confident about using these products, and if they're applied correctly and you cover all the bare metal, you should not have any corrosion issues even years down the road. So again, a lot of similarities between these products to begin with. Now let's talk about some very important differences. As I mentioned, we have one structural adhesive and two panel bonding adhesives, and there's a large difference between those two. So a structural adhesive is designed only to be used where the manufacturers tell us to use it. So you're going to need to specifically go to each procedure for each vehicle and specific year and find out where they recommend a structural adhesive. We don't want to use that just anywhere we feel is suitable. We have to follow the OEM recommendations. And one of the reasons is that it's a completely different style of adhesive. So it's got a lot of technology in this adhesive, including that it's impact resistant or crash toughened. And what that means is it's got a little more give to it than a traditional bonding adhesive. And when you run a test on these two adhesives, you see a noticeable difference in how they separate on impact. So this adhesive here will absorb a lot more crash energy, and it'll separate a little bit differently. Now, these adhesives here, the panel bonding adhesives, are mainly used for outer body panels. There's an exception nowadays with the Ford F-150, the aluminum vehicle, using 8115 on structural panels, but other than that, they are not intended for use on structural panels. So always follow these instructions very closely. Don't just toss these aside. It's a really good idea to review these occasionally and make sure you're following these instructions. So those are the main differences between these two products. And really, when you look at this, it's pretty obvious after these mock crash tests that there's a large difference between the two. You've got a panel bonding adhesive that collapsed in more of an uncontrolled manner and easier, and as you can see, did not absorb the same amount of energy as this crash toughened or impact resistant adhesive. So that's where the science comes into this, where it's designed to absorb energy and slow that crash event down. And you can see how much more energy this absorbed by the way it collapsed in a much more predictable manner. So really, those are the main differences between these products. So again, follow those OEM recommendations so you select the right product for that job. Okay, question number two. When do I use 8115 bonding adhesive versus 8116? So what are the differences? So the main difference is 8116 was specifically designed to meet General Motors and Chrysler specifications. And it's all about the mode of failure. In other words, for this product, GM and Chrysler wanted to see cohesive failure should the seams ever come apart or separate. And that allows for better corrosion protection versus if you have adhesive failure and there's separation, you would only have adhesive on one side and not on the other, which is prone to corrosion. So that's the main difference. There is a slight difference as far as clamping time as well. There's a slightly longer clamping time for the 8116. but the main difference again is in that failure mode. So now the other part to that question is, how do I know when to use one or the other? And obviously we're going to follow OEM recommendations, but I can tell you that for the 8116, Chrysler wants it used for all their bonding operations. General Motors also specifies 8116, but only for the door skin bonding operations. All other bonding operations for General Motors is now recommending the structural adhesive. So those are the differences, and those are where you would use each product. But again, it all comes back to getting into those procedures and following what the OEM says. All right, question number 3. Why do we need to equalize the cartridge and purge the cartridge? And the answer is pretty simple, but we still see a lot of this not being done. So what we're trying to do is, number 1, eliminate any air pockets that may arise inside these plungers, inside these cartridges. So by plunging the cartridge, it drives the air to the top, and that'll come out in the beginning. We also need to inspect the ports on the end of the cartridge to make sure there's nothing dried up or hardened on the inside. It's always a good idea to have a little pick where you can pull anything out of there that hardens up, especially once the cartridge has been used and stored. There's a good possibility of that happening. So we need to get rid of that material as well, so we have, a good flow of material going through the nozzle. Now, the other question we get is, why do we need to purge some material out after we've equalized the cartridge? And the reason is that when this tip is empty and we're pushing product through it, there's no back pressure on the material down here. It's just air above it, so it tends to flow through without going through that mixer very thoroughly. So once we fill this about halfway, now there's back pressure that forces it through that mixer a lot better. So that's why we want to just run out a couple inches of product before we start to apply it to the vehicle. So I'm going to gear up here and go through that equalizing and purging procedure so you can see what it looks like. So you may have noticed as I extruded the product from the cartridge that one side came out before the other. So had we not equalized that or balanced those cartridges, we may have had an uneven mix that may not have cured. And there's enough adhesive in that nozzle to put out a bead quite long where that whole area may not properly cure. So again, emphasize that importance about equalizing that cartridge to get a proper mix. Okay, question number 4. Do I have to remove the E-coat or galvanized coatings on the surface of the parts? And the answer is, again, follow OEM recommendations. However, there's a caveat there. Many of the OEMs will actually, in their instructions, state to defer to the adhesive maker's instructions for the specific procedures, only because the OEM does not always know which adhesive you're going to select for that particular vehicle. So the instructions may be slightly different. So again, familiarize yourselves with these instructions. This information is in the instructions, and it'll tell you whether or not you have to remove that coating. Now this sample here shows the difference between a surface that just has the primers removed compared to one where it's been abraded aggressively enough to remove all the galvanizing or zinc coating. So you can see a drastic difference between the two. Some vehicle makers refer to that as bright steel. They may say, remove all the coatings down to bright steel. So that means you abrade until you get that nice shiny surface and you know all the galvanizing has been removed. But there's no simple solution and one answer. It's always going into those procedures, whether it be the OEM or the adhesive maker's procedures, to find out what they recommend as far as removing the coatings. Now, as far as removing the E-coat, as far as the 3M 8115, 8116, and structural adhesive are concerned, we tell you to always remove the E-coat with one exception, and that's for 8115 and 8116 where they're used on door skins. It's allowable to leave the OEM E-coat intact as long as it's scuffed and properly cleaned, but only on the door skins. So really, not very complicated, but go back to the OEM and adhesive maker's instructions for the correct information. Okay, moving on to question number 5. Can I use heat to accelerate the cure? As I stated earlier, because of the epoxy chemistry of these products, they handle heat very well. So it's absolutely acceptable to use heat to force cure these products. As always, we want to observe those maximum temperatures. So our recommendations is about 150 degrees for 40 minutes, which will get you very close to full cure. Roughly 80–85% of full cure in as little as 40 minutes. So we want to observe that maximum temperature. We don't want to abuse it and overheat. You want to monitor that temperature closely, and it's a good idea to use something like an infrared thermometer where you can actually get the actual temperature of the panel rather than ambient temperature. So feel free to use heat, just follow the instructions to do so. Okay, so question number 6 is similar to question number 5, but the question is, can I put the product in the refrigerator to slow that cure time down? And the simple answer is yes. However, I would recommend maybe something a little less aggressive like an air-conditioned office rather than a refrigerator. But as long as you're monitoring how cold it gets, you absolutely don't want it to freeze, but just cooling that product down will give you a little more cure time. For climates like Texas or Arizona where it gets extremely hot, it's not a bad idea to cool the product down some, but keep in mind as it gets colder, the viscosity gets thicker. So just take care when you're extruding it out of the cartridge that you don't force it too hard. It may not go through the mixer correctly and get a thorough mix. Okay, question number 7. As far as when you see equivalents in a repair procedure, for example, it may say use 3M 8115 or equivalent, who do I listen to? And this is a tricky question. In order to avoid any liability issues, it's always a good idea to use the actual called out product rather than an equivalent. The problem with equivalents is it takes an engineering degree to really decipher whether it is an exact equivalent or not. It may not have certain chemicals in it. It may have chemicals it shouldn't have in it. So in order to say it's an exact equivalent is very difficult to say. So simply put, I would just recommend using the adhesive that's named in that procedure and stay away from the equivalents as much as possible. Okay, question number 8. Why do we weld bond? And that's a great question. So weld bonding is the combination of adhesives and welds in the joint. Why do we need both? Well, the adhesive adds a lot of benefits to that joint. One of the things is it prevents corrosion because you've got a completely sealed joint that you would not normally have with just welds. So it seals that joint to keep any moisture or air from passing through there and causing corrosion. Another reason is, in the case of the impact-resistant structural adhesive, it actually allows the part to collapse in more of a predictable manner and absorb energy as it collapses. Another benefit is you've got a continuous bond, not just a spot here and a spot there, it's continuous, so you get really good lap shear strength. The weld in there prevents the adhesive from ever going into peel mode and starting to peel. That's kind of the weakness of any adhesive is peel mode, and having that weld in those areas will prevent that from happening. So a lot of benefits to combining the welds and the adhesive together in weld bonding. Okay, number 9, can I weld through cured adhesive? 3M does not recommend welding through the adhesive after it's cured. It's really important that we follow the work time on the adhesive cartridge. In this case, it says 60-minute work time. You really want to get your welding complete within that work time. Actually having that liquid adhesive in there helps with the conductivity between these two panels when we're trying to spot weld through them. Once that adhesive cures, it actually acts as an insulator, almost like a gasket between those two pieces of metal, which do not allow for that conductivity from one side of the spot welder to the other. So the short answer is do not weld through cured adhesives. Okay, let's wrap this up with question number 10. How do I keep my bonded flanges from corroding? Now, if we had done our replacement procedure and our preparation perfectly, there really shouldn't be a chance of corrosion in that joint. As long as we've got all the bare metal covered, the adhesive has corrosion inhibitors and that should not happen. However, there's no guarantee that during the replacement of that panel, we could have maybe damaged or scraped off some of the adhesive in certain areas. A great example of that are quarter panels. When you hang a quarter panel, oftentimes you need to force it a little bit down onto that wheel arch area. And in the process of that, it is possible we could scrape some of that adhesive off and leave a void. So insurance against that would be Cavity Wax Plus. So as long as we follow all bonding operations with Cavity Wax Plus, which will get into those areas that might be exposed and cover them and creep in, you're not going to have that corrosion in those joints. Also, if you read the product sheets, these will tell you always follow all bonding operations with Cavity Wax Plus. Hey, I just thought of one more question, so you'll get a bonus 11 questions here. This is really important though. So the question we hear around the country is, how long will a cartridge last after it's been opened? And we've actually heard stories about people saying once the cartridge has been used once, even if it's half full or more, throw it away, it's no good, and that really isn't true. So really the answer to that is, as long as you leave the nozzle on when you're finished with the product and allow it to harden up and seal this cartridge, you should get very close to the original stated shelf life. It's also important that you know the shelf life of these products. It generally varies between 1 and 2 years. So as long as you seal it up correctly, leave that nozzle on, you should get close to that 1 year or 2 year, whatever it's stated. So don't just toss the product away after it's been used once. There's still a long ways to go with it. All right, that's it. Thanks for watching. Hope you enjoyed this video. Don't forget to hit the subscribe button and the little bell icon so you will know when new videos are posted. If you have any other questions about this topic or basically any others, leave us a comment below. We'll see you next time.